1255, April 4th, 2026. Right now marks 2,283 hours of progress on the global heart simulation. Currently, a accurate simulation of human vision using voxels has been created, and the system is been made to work in all three dimensions for the first time, as well as run performantly in real time. And so it's able to calculate, in this example, the line of sight for 125,000 voxels in a single frame with really complex line of sight behavior that is 100% accurate. It always blocks the minimal amount of voxels necessary to create the most accurate line of sight, and it also doesn't have gaps, so it doesn't allow for gaps, this method. And in order to look at the performance, it does appear to be very stable at the moment. And so, the demonstration, it works regardless of where the obstructions are and how many obstructions. And so, interestingly enough, blocking the voxel directly in front of the eye will block the entire site, which makes sense. So it works, it's modeled after human vision, though this example, since the voxels themselves aren't really limited to a certain field of view, they're basically 180 degrees horizontally and 180 degrees vertically. And so, in order to understand how this works, basically, for every voxel, the path to the eye is pre-calculated, and then in order to determine if voxels are blocked, they check their path towards the eye. That's seen here. And in the case of the voxel in front of the eye, its path ends at itself, and it is able to understand that. And so, now that this is finally working, three-dimensional line of sight blocking, which is the most difficult part of the proposed fog of war system, the idea going forward is to use the line of sight blocking to create a more different type of project with height fog and visibility blocking and hiding information, as well as turn-based systems. Yeah, this is very accurate. As accurate as possible, so it's 100% accurate, guaranteed, and it's also very performant. Although the current bottleneck seems to be not the real-time version or the real-time aspect of this, but actually generating the necessary data structure itself, as it does have to access the voxels in a certain order, and so ordering them and generating the data structure itself seems to be the bottleneck, as starting the program, it freezes for a few frames, so the program could go up to 1,000,000. It's been set to go up to 1,000,000, though starting it is frozen for a couple frames. So the idea going forward would be to optimize the generation of the structure, perhaps through parallel processing, though the actual update loop code for this would need to be done using classical loops, as again the voxels need to be accessed in a certain order in order to determine if their path is blocked. And so voxels at the start of the path take precedence. And so the intention going forward is to optimize the generation of the data structure so it can create the grid without freezing, though the real-time portion of the code is working well. And then after optimizing that, basically scale to a bunch of voxels, more than any other system could, as this is currently far faster than any sort of raycasting or physics-based implementation, and very accurate.